Okay guys, so in this video we're going to be talking about determining functions from tables, and we're going to be specifically looking at linear functions and exponential functions and kind of like comparing and contrasting what are the similarities and differences between them, and why do they have a special name. So basically you guys need to know a couple things. You need to know the basic formula, the basic equation for an exponential function and linear function, and you need to know what the critical values are for each one of these. So for a linear function, if we just concentrate on linear function right now, this is what you need to know for a linear function. So a linear function has the same slope everywhere. So the rise over run, or the slope, is the same everywhere. So now you can go, for example, up 1 over 1, right? So if you go up 1 to the right 1, you will get to this point. If you go, or actually I should say you will land on the line. If you go up 1 over 1, you will land on the line. Up 1 over 1, you land on the line. But it doesn't have to be that. Like, I can do any other slope. I can do, for example, I can go up, let's see, I can go up 3 and then over 3, and I still land on the line. So notice that instead of going up 1 over 1, I went up 3 over 3. I could also go up 2 over 2, and I still land on the line. Why is this possible? Well, if you think about it, 3 over 3 would be 3 divided by 3, which gives you 1, right? 2 over 2 would be 2 divided by 2, which gives you 1. Or you could have also said up 1 over 1, which is 1 divided by 1, which gives you 1. So what's special about linear functions is that they have the same slope everywhere. Now that slope typically is a constant value, constant number that you're adding every single time to get from one number to the next in a linear function. So that number that we're adding constantly is actually the slope, and it's going to be typically right here, right in front of the x. The equation is usually y equals mx plus b, or f of x equals mx plus b. I wrote it as f of x equals mx plus b, so you guys can know that it's the exact same thing. It's just function notation. Now b is called the y-intercept. It's where it touches the y-axis. Where does it touch the y-axis? Well, if you're looking at tables, the y-intercept will also be where x is equal to 0. Okay, so aka where x is equal to 0. And there's also a formula for slope. If you can't find the slope, like if it's hard to figure out the pattern, you use this formula, the slope formula, y2 minus y1 over x2 minus x1, which sounds confusing. Well, all it's saying is that you subtract the y's and put it over the x's subtracted as a fraction. And then we'll do some examples of that. So linear functions, again, the whole point of this, linear functions are relationships in which you add or subtract. So adding or subtracting a constant value every single time. So that being said, if we have an exponential function relationship, so I'm not looking at linear for right now, I'm just looking at exponential functions, and then we'll compare them. So an exponential function differs in that an exponential function, you're actually multiplying or dividing by a constant amount each time. So linear was add or subtract, exponential function was multiplying or divide. Now this is the formula for an exponential function, a parentheses b to the power of x, or a times b to the power of x. Again, in the other video I kind of showed you guys what these guys represent. A is the y-intercept. Same thing as the last time. It's where x is equal to 0. So that's not going to be a struggle for you guys because you've already done it before. So to find the y-intercept, look to see where x is equal to 0, and it's right there. The multiplicative factor, you have to think a little bit about this. It's what you actually are what you're actually multiplying or dividing, because it's exponential, and that will be your b. So your job is your job is figure out, first of all, is it adding or subtracting, or multiplying or dividing? And then that'll tell you, hey, I'm going to use this formula for multiplying or dividing. And if it's adding and subtracting, you're going to say, hey, I'm going to use this formula because it's adding or subtracting. So you have to know that. Are the functions being added and subtracted, or multiplied or divided by a constant number? And then you know which formula to use. So it's either going to be this one or this one, either or. Okay, so that being said, let's do some examples, and then we will call it a day. So I'll leave those formulas here so you can see them. So from lowest to highest, we have the x -1 all the way to +2. So from here to there, from there to there, from there to there. There's a pattern going on for the first one, right? So I'm going to write what's going on up here. This is actually getting smaller from left to right. And if you notice, you're not subtracting, right? If you notice the pattern is actually a division problem, you're actually dividing by 4. So I'm going to write here as divide by 4 as our general pattern. Now, If we know that it's division, I'm not going to use that formula at all. I'm going to use this one because we know it's multiplication or division. So it's going to be a parentheses b to the power of x, or a times b to the power of x. All I got to do now is figure out where x is equal to 0 for me to find my y-intercept, and that value is going to be here at 12. So for the first one, I got everything I need. My function is, so I go from a table to a function, is going to be a, which is 12, times b, which is, well, we said we're dividing by 4, so it's going to be 1 over 4 to the power of x. Now notice that I put divided by 4 as a fraction. When you have division, it's not going to be a whole number, it's going to be a fraction, signifying that the value is getting smaller. So there you go, there's your first function. So you go from a table to a function based on the relationship, whether it's adding, subtracting, multiplying, or dividing. Okay, next one. So let's figure out the next relationship. So this one, 2 turns into a 6, 6 turns into an 18, 18 turned into a 54. It's getting bigger, but it doesn't seem like we're adding. It seems like we're multiplying. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So we're actually multiplying by 3, right? So multiply by 3. Now we just have to find where x is equal to 0. So look at the x values. The x value is going to be 0 here at this function value of 2. So we know what should go on the outside. We know that it's multiplication. Notice that it's multiplication, so I'm not looking at this function still. I'm looking at this one, right? A times b to the power of x. So the formula that I'm going to use is that one. A would be equal to 2. B would be equal to multiplication by 3. So I'm going to actually straight up write 3. And that'll be to the power of x. So it's going to be 2 parentheses 3 to the power of x as my final function relationship. Okay, example number 3. Same idea. Let's try to figure out the pattern though. So from left to right, 1 turns into 3, 3 turns into 5, 5 turns into 7. So it looks like we're adding 2, right? 1, 2, 3, 4, 5, 6, 7. So we're going to say that this pattern is adding 2. Notice that we're adding. I'm not using the middle function now, so I'm not even looking at it. Adding and subtracting, I'll have to use y equals mx plus b, or f of x equals mx plus b. The number that you're adding or subtracting will be in front of the x. So we're adding 2, and then the y-intercept would be b, which is also where x is equal to 0, kind of like the other ones. So I'm going to highlight that one. So I'm using the formula y equals mx plus b, or f of x equals m, which is adding 2, so it's going to be a positive 2. X, and then plus 7, because the y-intercept puts at positive 7. Okay, let's do another one. So same idea. So from left to right, it's 10 turns into a 7, 7 turns into a 4, 4 turns into a 1. It looks like we are subtracting here. It looks like we're subtracting 3. So since we're subtracting, again, I'm not looking at this. I'm looking at y equals mx plus b, right? So that's going to be my function that I'm going to use. Since we're subtracting 3, we're going to be using the formula f of x is equal to negative 3 because we're subtracting. That slope would be negative 3. We're going to put an x, and then we're going to have the y-intercept be at x equals 0, which happens to be where the function is equal to 4. So we're going to put a plus 4 at the end. So f of x equals negative 3x plus 4 would be our final answer. Okay, and then the very last one. The reason why I made it the last one is because it's hard to figure out the pattern, right? So let's check it out. So 3 turns into 10, 10 turns into 31, 31 turns into 59. Wait a minute. Okay, let's check. So it's getting bigger, so it's either adding or multiplication. So let's see. 3 plus what will give me 10? So that would be 7, right? But 10 plus 7 is not 31. 31 plus 7 is not 59, so that doesn't work. Okay, let's check multiplication. What the heck do I multiply 3 to get 10? What do I multiply 10 to get 31? 31 to get 59? Well, the reason why this is hard to figure out is because if you notice, all the other ones, the x's were in order. Negative 2, negative 1, 0, 1. Negative 3, negative 2, negative 1, 0. 0, 1, 2, 3. Negative 1, 0, 1, 2. So they're all in order. In this case, we don't have the x's in order. It's negative 1, 0, 3, 7. So it skips around. So for that reason, we have to check a different method. We have to check the slope to see if the slope is the same. If the slope is the same everywhere, right? If the slope is the same everywhere, then we know we have a linear function, and it makes our life easy because we just plug it into that. If the slope is not the same everywhere, then we have to use a different method. So let's check it real quick. So we're going to use the formula y2 minus y1 over x2 minus x1, which is just a fancy way of saying subtract the y, subtract the x's, and you pick whichever y's or x's you want as long as there are 2 points. So I'm going to go ahead and, what looks easy? I'm just going to go ahead and use the 3 and the 7 and the 31 and 59. So I'm going to subtract the y's. I'm going to do 59 minus 31. And then put it over subtracting the x's, so that would be 7 minus 3. So I have to go in order, right? So I did this one minus that one, so I have to do this one minus that one. That way I can make sure to get the right sign and the right number. So 59 minus 31, that gives me 28. And then 7 minus 3, that gives me 4. Now if I take 28 divided by 4, I get 7. So my first slope is equal to 7. So we have 1 between these 2 points. All right. Let's check another 2 points, and then we'll see what slope we get if we check 2 other ones. So I'm going to go ahead and just cover these ones. Those look easy enough. I'm going to go with the 31, 10, and then the 3, 0. So I'm going to do the same thing that I just did. I'm going to take 31 minus 10, so 31 minus 10, and put it over 3 minus 0. If I do that, I get 21 on top over 3 on the bottom, which is 7. Uh-oh, wait a minute. So this is the whole idea here. We got the same exact slope for those 2 points that we picked at random. Since we got the same exact slope, that means that basically we know that it's going to be a line. We know that it's going to be a linear function. There's no more guesswork. We know that the formula was going to be this one, f of x equals mx plus b, right? We just basically have to plug everything in. Well, we know the slope is equal to 7, right? We just figured out that it matched up 7 for both sets of points that we picked. So there's my first part of the function. F of x is equal to 7x. And then we have to add b to that. Well, b, that's still the same thing that we had for the other problems, is where x is equal to 0. So we look to where x is equal to 0. That happens to be a 10. So the b is going to be plus 10. So my final function, my function for this table that they were trying to trick us and confuse us because they give us some random numbers that we couldn't figure out the pattern of, we still figured out the pattern. So check the slope, any 2 points. If the slope is the same, then we know that it's a linear function. Right away we have our slope, put it in for the m, and then plug in your y-intercept as your b. Okay, hope this video was helpful. Good luck. If you have any questions, let me know personally. See you on the next one.